We're going to talk about solving radical functions. You've probably done some very basic examples of these before, and they're not, I don't think they're very difficult. You've got these steps up here. So step one is to isolate the radical if it needs to be isolated. A lot of times it will already be isolated. I've heard some students in the past refer to this as they're going to solve for the radical, and that's the first step. Okay. And so all that means is, and you can just kind of, you don't have to write this example down, just follow me up here. Right. If you had this and you're having to solve it, to isolate the radical, to get this part of the equation by itself, it would be the exact same steps as if it was that right there. What are the two things I would need to do to solve for x? Subtract 3 and then do what? Divide by 2. So to get the radical by itself, the first two steps would be the exact same thing. I would subtract 3 and divide by 2. Alright, again, a lot of times the radical will already be isolated. In fact, what is the only example of these 6 that does not already have the radical isolated? Number 5. It's got this plus 3 at the end. All the other ones on the left side of the equal sign, okay, we'll talk about 6 whenever we get there. The radical is all by itself. Step 2, you're going to raise both sides of the equation to the nth power. We put nth on there because if it is the square root, how do you get rid of a square root? You square it. How do you get rid of a cube root? You cube it. Okay, so those are really the only two we're going to deal with. So you'll either square it or cube it to get rid of the radical. Number 3, you'll use algebra to isolate the variable. You'll solve for x at that point. Okay, the radical will be gone. And then on 4, you'll check to see if you have an extraneous solution. We won't get to that until the bottom of this page, that example 7 at the very bottom. So we'll kind of talk about that there. Okay, so let's go through those steps on these 6 problems. A lot of these are going to be very short. For example, number 1, what do I need to do to it? I need to square both sides, so x equals what? 9. Okay. Number 2, Michaela, what's the first thing I would need to do? Square it. So I get 2x equals 16. So Chris, what does x equal? Thank you, Zoe. Yeah, what Zoe said. You need to square it. Mark, after that, what do I need to do?
Subtract 1.
And then?
Divide by 3.
Okay. Carson, on 4, what do I need to do first? Cube it. Delaney, what's the next 2 things I need to do?
You add 3, and then you divide by 2.
Carly, what's the first thing I need to do on 5? Subtract 3 first. Okay, so there's the difference if the radical is not already isolated. You're going to have to move everything away from it first. And then now, Carly, what do I need to do? Then square it. And Jessica, what's the last thing I need to do there?
Subtract 13.
Subtract 13. Alright, so looking at 6, you've got a radical, and then it is subtracting another radical. How I would solve this one is I would add that second radical to the other side. Okay, and to be completely honest with you, most of these kind of problems, this is how you'll see it anyways, where they're already set up equal to each other. Okay? These, in my opinion, are easier than maybe all of them but number 1. Okay, because you would square one side to get rid of the square root, which means you have to square the other side, which will get rid of that square root. So this problem, you would solve it as if it didn't even have any radicals on it at all. Okay.
But isn't it what equals?
Then again, after that, you just solve, so subtract 3x, subtract 3, x equals 2 on that one. Questions on solving just kind of basic radical equations? Yes, ma'am.
So if you bring it,
Alright, let's go down here to the example about the extraneous solution. So, same process. Let's go ahead and solve this out. Alright, so Abby, what would be the first thing I would need to do on this one? Okay, whenever I square the left side, is that just going to become x squared plus 1 squared? No. What do I need to make sure to use? Parentheses. Okay, if you're squaring a whole side of an equation, you've got to put that whole side in parentheses. I've got a lot of people who know the steps, they do that part wrong. They just write it wrong and get the wrong answer. So if I have that, that's going to end up giving me 2 of these right here. I would then need to do FOIL on the left side of the equation to get x squared plus 2x plus 1 and then whenever I end up with something that looks like that, what do I need to look to do? Factor it. Before I can factor it, Dylan, what do I have to do to it? Before I can factor it, what do I need to do to it? Manuel, help him out.
Set it equal to 0.
Set it equal to 0. Subtract x. Subtract 3. And then now, somebody tell me what factors of negative 2 add up to positive 1? The other way around. Positive 2 and negative 1, which then give me what 2 answers, though?
negative 2 positive.
There you go. Okay, so if you end up with quadratic, just like always, you're asked to solve. You end up with quadratic, look to factor it. You get 2 answers. Now, the extraneous solution part of this problem. If you get 2 answers, which means you had to factor, you've got to take each one of those. You're going to plug them back up into the original problem. And the one that makes the problem false is the extraneous solution. Let me kind of walk through it before you ask examples on how that works. So, first I'm going to put 1 in there. So I've got 1 plus 1 equals the square root of 1 plus 3. Hopefully we can all agree that 1 plus 1 is 2 and 1 plus 3 is 4. Is the square root of 4 2? Yes, that's a true statement. So that is an actual solution. That's a real solution in this problem. Next, we got negative 2. So I'm going to plug negative 2 in for x. So I get negative 2 plus 1 equals the square root of negative 2 plus 3. I get negative 1 equals the square root of 1. Alright? And so, whenever you're doing this, we want to only consider the positive solutions. So, and I'll tie that back into, I believe it was 10.3 lesson. So, because I got the negative answer of this, the square root of 1 is negative 1, this would be my extraneous solution. Okay, and that's just a fancy word for extra. Alright, it's not an actual solution to the problem. Those extraneous solutions, if you can think back to 10.3, whenever we talked about taking the inverse of a quadratic equation, and it ended up giving us a horizontal parabola, the extraneous solutions are going to be points on the part of that parabola that we had to get rid of so that it could be a function. That's where those lie. Okay? So, if you're able to graph it, okay, a lot of times you'll be able to see, if you graph this in y1 and this in y2, you would be able to see the x value that it did cross. Alright, and if you've already factored this, that could tell you that the other one is your extraneous and you wouldn't have to do this part. Okay, that's kind of another way to do it. Sometimes I think just plugging it in and finding it is a little bit easier. Now, just because you factor it doesn't mean that you will automatically have an extraneous solution. Okay, let's say the linear part of that problem gave you that linear line. Come on now. That line. And so you would have 2 points where it cross, so you would have 2 actual solutions. Okay, so you will not always have an extraneous. The majority of the time you will have one, though, whenever you have to factor it like this one. Alright, so flip over to the back. Let's go through this word problem. It is not very complicated at all. A lot of the word problems in this unit, it's going to give you just a random equation that has a radical in it. And the majority of the time it's just going to involve plugging a number in for one of the variables and doing what we did on the front of the page, which is solving it. So, it says the speed of sound near the Earth's surface can be found with the equation V equals 20 times the square root of T plus 273, where T is the temperature in degrees Celsius. What temperature is the speed of sound? For what temperature is the speed of sound, the velocity 356 meters per second? So, it tells me what V needs to be, and I'm just going to find T. So I plug 356 in for velocity. And if I am solving for T, Peyton, what would be the first thing I need to do? What is the first thing I need to do? Okay, I would subtract 20 if it was that. But if it's 20 times the square root, no. Divide by 20. Okay. Which whenever you divide, what is it, Carson? Okay, you get 17.8. And then after that, Allie, what do I need to do? Okay. Square both sides. If I square that, I get 316.84. And then Dylan, what is the last thing I need to do to solve for T there? Subtract 273. So the temperature that you get is 43.84.